Last week we have discussed about kinematic, betul Displacement, velocity, and acceleration. Betul?
Betul Ustaz?
Betul. Saya ada tiga kelas biomax, so saya mix up kadang-kadang. So please, kita kena recall sikit-sikit. Nanti kan saya ajar kamu, patut ajar lain dah sampai kat lain lah. Okay, kalau betul, this week we are going to talk about why those kinematic happen. Minggu lepas kita tengok kinematic, we have velocity. Oi, apa ni? Saya tekan ke? Sekejap We have velocity, we have acceleration, and we have displacement. In other words, last week we have talked about dynamics. Okay, we are talking about dynamics, means we have change of place, and that change of place caused by change of velocity, means there are acceleration. Okay, so today we are going to talk about why that things occur, why acceleration occur, and what is the properties of an acceleration. Properties that make things move, that make things have motion. And to do so, we are going to discuss about the law that being followed by motion. Okay, law of motion. Right. So first and foremost, we can define law as a principle or regulation or a collection of rules. And the best part of it, when we talk about law of motion, yet until today there are no motion which disobey the law. Dia memang mengikut law itu. Dia memang mengikut those principle. Dia memang mengikut those regulation. Dia memang mengikut those rules. And by having so, we can have all the movement that we have today. Kalau kata motion ni, motion yang paling mudah sekali, we define motion as movement. Okay? As movement. Ada banyak lah kat sini. But as for me, when we see the term motion, okay, motion pictures means pictures that move. Okay, so before this, when they do cinematography, it consists of unmovable pictures, and they are going to paint one by one in sequence in order to make it move. And when the still pictures become move, it is known as motion pictures. Okay, ni kan ada pembuat filem nama motion pictures kan. So motion is movement. So law of motion is a set of rules that being followed by movement. Kalau law of motion ni tak ada kan, example when I just toss this pen, it won't goes down. Tu maksud dia. It goes wherever it's try to go. Dia ada kepala dia sendiri if there are no motion. Okay, for another example like this. If we have an object, we kick the object goes this way. Boleh tak benda ni berlaku? Can this kind of movement occurs in our world? Or maybe we have an object and we just leave it there. Suddenly, it start moving with an amount of velocity. Can this kind of motion occurs in our world? Boleh tak? Kenapa? Boleh tak dia jadi sini? Kita tengah baring kat bilik, suddenly sampai dekat kelas. Suddenly, in a sudden, buka mata je, alamak aku dekat kelas. Something like that. That only occurs if motion in our world does not obey their laws. Okay, boleh dengar tak ni? Can you hear me?
Boleh saya, boleh
Dengar saya.
Right. Saya takut saya cakap sorang-sorang. Itu law of motion, okay? Means that set of rules that being followed by motion. So, there are three very distinct law of motion. Okay, kalau kita cerita law of motion, ada tiga. Plus one. 3 plus 1. The another one is law of gravitation. But the most important in order for us to describe motion is actually these three laws. law of inertia, law of acceleration, law of action, reaction. Okay, ni ada lagi satu, action, reaction. And these three law is interrelated with one another in order for us to describe motion ataupun pergerakan. So let's go one by one. The first law is also known as law of inertia. Okay, ni la 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 la. Okay, so law of inertia ni benda macam ni. When we try to describe law of inertia, do you still remember our topic about equilibrium? We have discussed that one, right?
Yes, sir.
Yang mana kita ada FH, FV, and another one in terms of rotation we have T. So when we talk about equilibrium, it is a state without acceleration. Okay, means without acceleration, if the object does not move, it remain unmovable. If the object move, it will remain movable with the same velocity ataupun constant. This is a concept of static equilibrium. Okay, ni static. And this one is the concept of dynamic equilibrium, with both sharing the same variable, constant. Constant apa? Acceleration. So if you don't have acceleration, you're not going to move. Tak ada force sepak ni, tak ada acceleration lah. If you are in moving, you are going to maintain the same course, maintain the same speed throughout the places when you don't have acceleration. Okay, this is the concept of equilibrium. Means in an object, the net force is 0, or FH equals to 0, FV equals to 0, and torque equals to 0. Combination of these three type of force resulting F net ataupun F total equals to 0. Meaning there are no force. Okay, there are no force subjected to this object from any direction. No force at all. Which resulting a state of equilibrium. Which equilibrium? It depends on the velocity. If there are no velocity, static equilibrium. If there are velocity but constant, dynamic equilibrium. Itu konsep asas dia. Okay, this is the concept of law of inertia. This is the concept. In other words, law of inertia talks about equilibrium. Okay, a body will maintain a state of rest or constant velocity unless acted on by an external force that change the object, the state. So the change of this state is giving an acceleration to the object. So the first law said that no force, no change. Okay, no force, no movement, static equilibrium. No force, that movement is going to be constant, dynamic equilibrium. So if you want to change the state of that, we need to inflict external force. Okay, external force. So at the first case, for the static equilibrium, object does not move. If we inflict force, it will cause the object to have an acceleration. And when that occurs, it will have velocity. In other words, the object will start moving. Itu yang pertama. Okay, kalau case static, meaning that static will become dynamic. Second, in terms of dynamic equilibrium, the object does move x meter per second. And when we inflict force, it will cause the object to have an acceleration. And this acceleration will make the velocity increase, a new velocity. Maybe v equals to x plus y meter per second. Dia menjadi melaju lah, melahu. If the force being applied in different direction, it become -y, something like that. In other words, you are going to have acceleration. You are going to have acceleration. And when you have acceleration means there are no more inertia. There are no more equilibrium. There are changes. Tu cerita Newton's second law. So Newton's first law ends here. A body will remain unmovable or a body will move with a constant velocity unless we inflict external force. So no external force, no change to the system. Letak bola atas padang, it won't go by its own unless you kick that. Tu maksud dia. Maksud law of inertia. Berdiri tegak-tegak dekat padang perhimpunan, if nobody push you from behind, you are not going to move. You're going to be there. Kecuali kamu tengah duduk elok-elok atas kursi, tiba-tiba you notice you are moving on its own. Okay, baca Yasin. Itu disobey the law of motion. Most of the object inside our world obey this law. Okay, so motionless object remain motionless. Everybody will remain at rest or moving with a constant velocity in a straight line unless there are external force. So if we want to change the state, inflict external force. That is the first law. Okay, if there are no infliction or any sort of force, no change is going to occur to the system. Contoh macam ni. If this apa ni? apa sukan ni? Gliding ni? Ice apa? Ice apa?
Ice skating.
Ice skating. Okay. Kalau kita assume, if we assume there are no friction. Okay, there are no friction. This ice skater can actually glide until the end of time. Kalau kita assume there are no friction, but eventually we have friction in the world lah. So this skater is going to stop. Untuk cerita Newton first law, we are going to neglect friction. So based on this one, the skater has a tendency to continue gliding with a constant speed, with the same direction, because of inertia, because it has momentum, and the momentum will remain. Okay, unless there are external force. So this external force can increase the momentum or can decrease the momentum. Itu maksud first law. Sampai mana dia akan gliding? Sampai dia langgar dinding, or if there are no dinding, kita assume dia glide dekat kutub utara, he won't stop. Sampai the end of time. Itu maksud Newton first law. External force cause changes. There are no external force, no changes towards the system. Okay, contoh macam ni. Kalau dia tak kayuh, tak bergerak. Itulah maksud dia paling simple. Kalau dia nak gerak, dia kena kayuh. That is the simple description of the first law. Okay, and when we talk about dia kena kayuh and the bike is going to move forward, that is actually a second law. Now we talk about external force. Okay, the first law talks about system, change toward the system, and this change can only occur when you have external force. Now, in Newton's second law, we are going to talk about the external force. Okay, so Newton's second law expressed the relation between force, mass, and acceleration. In other words, if the mass is constant, berat orang tak berubah kan, kalau dia bergerak daripada A ke B, the berat is going to be similar. Kalau kereta tu 1000 kilo, bergerak daripada Johor sampai Perlis, it will remain 1000 kilo. That is the meaning of it. So, if the mass is equal, force will directly affected acceleration. In other words, when you increase force, you're going to get more acceleration. Or, if we see something accelerating, means it has more force. Okay, itu yang pertama. Okay, konsep yang pertama. Force cause acceleration. Newton first law pun cakap benda yang sama. Force cause changes. So Newton's second law further explain this one. Force cause an acceleration. And now, what it actually express is actually, banyaknya actually. What Newton's second law really express is the properties of the acceleration. Okay, so dekat sini kita ada beberapa benda yang kena hafal. Okay, we know that when we inflict force from the leg to the ball, it will cause the ball to move. Okay, it will cause the ball to accelerate, which eventually give the ball some value of velocity. So bila ada velocity, dia akan ada satu benda lain. Nama dia natang ni. Kita dah bincang belum natang ni? Do we discuss about this one? Or not yet?
Not yet.
Okay. Natang ni, momentum ni, nama mudah dia is amount of movement. Berapa banyak pergerakan. So, how will we try to explain amount of movement? We are going to use momentum. Formula for momentum is momentum M besar equals to mv, small caps, representing mass of the object and velocity of the object. Okay, so now we can see it clear. Amount of movement ni dia. So when you have V, you are going to have momentum. And how momentum presence in a system is caused by force which being inflicted to an object. So when there are collision, pelanggaran between object, there are one properties occurs here. And this properties known as impulse. Okay, so formula dia is capital I equals to F T, which is F representing the amount of force and T representing the amount of time. So this time can be variation. First example, time of contact, that time. Okay, contoh bola kan, bila kita sepak, bukan bola tu terus pergi tau. It takes several millisecond contact and you are going to have some sort of attachment before the follow through and the ball start to move forward. So you start at the contact point, attachment and point of release. That is the time period. So the longer the time period, more impulse. Okay, itu time yang pertama. Time yang kedua is this one. Okay, contoh, kita ada kaki. Orang pertama kick the ball like this. Orang kedua kick the ball like this. Means I try to show you here the second type of time is the range of motion. This is a shorter range of motion compared to longer range of motion. So a shorter range of motion will have less time compared to a longer range of motion. Nanti kita tengok kenapa, apa beza dia dengan yang ni. Jadi time contact. So kita nak time contact ke time range of motion. Impulse works along the way. Okay, kita tengok konsep. So you have impulse. When we have impulse being given to an object externally, okay, this is an external force. It is originate from the leg, contact or collide with the ball, which transfer the impulse. And when an object had an impulse, that object automatically will have momentum. Dia akan bergerak. Sekarang kita cerita pergerakan dia. So based on Newton's second law, there are several properties of movement or of acceleration. Number one, okay, the amount of movement or change is directly proportional to the amount of force being applied. That is the first one. Meaning, if you give more force, you are going to get more acceleration ataupun more movement. Point yang pertama. Point yang kedua, the movement of the object is in the same direction of the force being applied. So if the force is from left to right, the ball is going to move right. Dia tak ada macam ni. We give force from left to right, ball move that way. No. Kita bagi force diagonal, ball goes U-turn. No. We give force ke atas, ball goes ke depan. No. So the second point said that if we give the ball a force from a direction, the ball will move to that direction. Yes. If we give the ball from this direction, the ball is going to move forward. Yes. If we give the ball some vector in terms of force, so kita ada rotational force, the ball is going to move as the same direction as the force being applied. This is the second properties. Okay, number one, force being applied cause an acceleration or cause change of motion in magnitude. Okay, so mean that the acceleration is proportional to the amount of force. Number two, the object will move in the same direction as the force being applied. And number three, inversely proportional to the mass of an object. Meaning, if we give force to an object 10 Newton. Okay, katalah objek ni 10 Newton. Will this ball move or will it not? Bergerak ke tak bergerak agak-agak? Dia berat 10 Newton, kita bagi force 10 Newton. Can this force move the ball? Boleh tak? Tengok nombor dia. Can it move? Can it move?
Takut saya.
Kenapa?
Yes.
Padahal, kenapa? Kenapa dia tak gerak?
Sebab dia equal.
Sebab dia equal. Okay. Sebab dia equal tu betul. But if we talk about equality here, kan kita bagi 10 Newton dalam jarak dalam arah ini. Kenapa dia tak nak bergerak? Is there any other force works at this particular object selain daripada force ini? Okay, contoh kita letak ni force 1. So selain force 1, ada force lain ke yang bertindak atas objek ni pada setiap masa? I don't see any.
Tak ada saya.
Tengok tu betul. Force we describe in term of Newton. Same as object weight, Newton. Meaning, if this Newton is a force, this Newton also a force. Soalan dia sekarang, force ni bergerak ke mana? Itu je yang kamu nak kena tahu. So, this 10 Newton is also an amount of force. Okay. From where this 10 Newton occurs is from mass. We multiply with gravity. So, we talk about gravity. What is the direction of gravitational force? Negative 9.81. Negative. It move like that. Okay, saya bawa ke sebelah. Okay. It move like that. Itu perkara pertama. So, what caused this object to be unmovable? Simple. When it moves downwards, means it's going to create something here. And this is friction. So if we push the ball from left to right, friction is another type of force which will works in vice versa direction. Means at the same time you are going to have to overcome the threshold of friction. Jadi kalau barang ni 10 Newton, threshold dia 10 Newton lah. So if we apply, okay, kalau kita kira total force, if we apply 10 tambah dengan this one will be negative 10, net force of the system is going to be 0. So there are no movement at all. This is the reason why. Okay. But if we change the amount of force given here, we change it to 20. Okay, so the new total of force for this system is 20 plus 10. So you end up dengan 10 Newton, which give you meaning of it moved to a certain direction. And the direction here will be positive lah. It moved to a certain direction. Means this object, after being applied 20 Newton, it will move at the same direction of the force, proportional to the amount of force, and inversely to the weight of the object. Jadi tak semestinya kalau kita kata benda ni 10 Newton, kita bagi 10 Newton, dia boleh bergerak. So, you need to overcome the threshold. And this threshold came from the weight of the object, which causing friction. Jadi kalau kita nak tengok, okay, now we go for 30. If we go for 30, instead of 10, dia dah jadi 20. This is the meaning of proportional to the magnitude of the force being applied. If we go 40, it become faster. Which direction? As the same as the force being applied. And inversely proportional to the mass of the object. That is the meaning of Newton's second law. You give force, it will accelerate. But don't think about, I give 10 Newton, that going to accelerate 10 Newton. No, you need to overcome the body mass first. And then you are going to get the acceleration. Itu cerita yang kedua. Okay, cerita yang pertama, no force, no change. Cerita kedua, we give force, it will be change. Change macam mana? More force, more acceleration. The object will move at the same direction of the force being applied. And there will be friction. Means you need an enough amount of force in order to make it move. Okay, ni contoh. Lagi banyak force, lagi laju dia berjalan. Tapi ada tendency, bila kita bagi force, but the bike does not move. It can't move simply because the friction is more than the force. Overcome the friction and you are going to move. Okay, itu dulu. Right. So, let's talk about this one. Force, cause, movement. Yalah, di sini. Okay, so we have force. It will cause movement. Okay. Means that object, when we have collision, external force being applied, it will cause this object to have momentum. Ini cerita dia. This is what we call principle of impulse momentum theorem. Okay, so I'm going to lay down the basis information. First, we know that force is always equals to the mass of the object multiplied with the acceleration. That is the base of everything. Number two, we know that impulse is a combination of force in a period of time. And number three, we know that momentum is the amount of movement of an object. Okay. So, please observe this one. We are going to start here, and I'm going to prove that these two things occurs. Okay. If we work with this formula, we are going to have, kalau kita gunakan formula yang lebih besar, acceleration can be substitute with velocity final minus velocity initial of an object divide with time final minus time initial. This is what we have learned last week. Okay. In mathematical equation, if you see something like this, velocity final, velocity initial, same variable, different time frame, we can actually write this out as the change of v, and same goes down here. It is the same properties, time, the change of t. Now we are going to move the lower part to the left hand side. So it will be F change of T over 1. Ni kalau kita terbalikkan lah. Sama dengan M change of V over 1. So this will become F change of T equals to M change of V. F change of T is this one. M change of V is this one. So we can have it as I, since I equals to Ft and M equals to Mv, so I is equals to M. This is I, this is M. Or we can have it like this. I also equals to Mv and M is equals to Ft. All of this thing is true. This is what we call impulse momentum theorem. Theorem or theory which show the relationship between impulse and momentum. And this theory, this relationship derived from the root of law of motion. F equals to ma. Jadi dengan kata lain, when we have impulse, we are going to have momentum. We increase the impulse, we increase the momentum. We increase the impulse, velocity increase. Velocity increase, force increase. Itu impulse momentum theorem. Later on, we are going to see some example of it. Okay, sampai sini dulu. Can you understand? Do you have the idea, the relation between these two? Dapat tak? Dapat tangkap?
Dapat, sir.
Okay, right. To make things easy, this talks about law number 1, law number 2. Law number 1 said that there are no change if there are no force. So if there are force, there are change. Settle. Law 1, law 2. So it being described clearly by impulse momentum theorem. Okay. And the third Newton law is known as law of action-reaction. What you give, you get back. Tenang. For every action, there is an equal and opposite reaction. The meaning is something like this. Okay. Let's say we have a person. And this person jumping. Jump ups. The same person in second situation also do a jump up, but the jump is just, it's not that far. Okay. This is known as A, this is known as B. So A jump higher compared to B. The reason is simple. We are going to say, in order for us to jump high, we need to push hard lah. Yes, push the floor harder. So Newton's third law said that for every action, there will be reaction. But this reaction will have different direction. Okay. So in order to get this high, let's say, this fella inflict force that much. It inflict negative 100 amount, negative 100 Newton of force downward, which cause the floor to return an amount of force upward. And that amount of force is the same as the one that being inflicted, but in different direction. This one is negative, this one is positive. Same goes here. Why this one jump lower? Because maybe here the inflicted force is just a portion of it. So it will be written as similar as being given. This is Newton's third law. Okay. Contoh. Ambil tangan sendiri, tepuk meja. Pelan dengan kuat. You're going to notice when you slam the table hard enough, you're going to feel pain. It is because when you inflict force to the surface of the table at the same time, the surface of the table inflicting the same amount of force, towards your palm. So you are going to feel pain. Tu maksud Newton third law. There are no one-way direction. It will always be two ways. Okay, ataupun kita tengok ni, kita tengok sprint start. We have 100 meter sprint start. Okay, we can see that some of the players have a good launch. Some of them, although use the same sprint start block, the same setting, but the jump is just, or the thrust is just smaller. Okay, FB, FE is larger than FB. Why? Because for FE, the amount being inflicted to the starting block is larger. So you are going to get larger outcome compared to B, which is smaller. So the outcome will be smaller. Tu maksud dia. Meaning, dia masih lagi menceritakan Newton's second law. Dia masih lagi menceritakan FME. In order to get good acceleration, you need to inflict good amount of force. That is Newton's third law. So when one body exerts a force on a second, the second body exerts a reaction force that is equal in magnitude, number of force, amount of force, but opposite in direction. If the first one move from left to right, the second one will moving from right to left. Itu tiga Newton law which governing motion. Motion kita boleh nampak sekarang. Itulah penyebab dia. This is the law that make it happen. Okay, and the last law, ni benda yang tadi tu. Reaction. The last law is law of gravitation. This is just a concept. Okay, this is just a concept. Okay, I'm not going to go in depth this one lah. Okay, cuma konsep dia simple. The concept is something like this. Kita ambil manusia dengan bumi. People will always say that we've been attracted by the Earth's gravity, but the fact is that we attract the Earth at the same time the Earth attract us. Okay, kita ada gravity sendiri, bumi pun ada gravity sendiri, but I name it as gravity Earth, gravity human, but gravity Earth is larger than gravity human. So we are moving towards the gravity. Why they are larger is because of several factors. The first one, proportional to the product of their mass. The larger the mass, the larger gravitational force you have. And then inversely proportional to the distance. Okay, inversely proportional. Lagi dekat, lagi kurang kuat. Lagi jauh, lagi kuat tarikan gravity dia. So as for the fighting between human and Earth, surface of the Earth, who have the largest amount of gravity, jawapan dia terletak dekat statement pertama. Okay, all body are attracted to one another with a force proportional to the product of their mass. So if you have more mass, you are going to have more force in terms of pulling other towards you. Itu law of gravitation. So we are not going to touch this one in depth. This is just a concept. Okay, right. We are going to take a break, and we are going to meet again at 10:55 with type of motion. Okay. Alright. This is some type of motion that we may have in the world. Saya tunjuk terus lah Maju sikit dia. Okay. In order for us to describe the first three type of motion, we are going to take example of human motion. Let's take an example of an action of kicking. Okay, so in order for you to kick a ball, this is the action, contact. If we see this action, the action of kick, okay, the action of kick itself as a whole, this is known as a linear action, because the leg change places linearly. Okay, kalau kata kita buat koordinat kan, kita ada kaki at this point, and towards another one we have the leg at this point. So they are displaced, and this is known as linear motion. To be exact, linear motion can be divided into two. One is known as rectilinear, another one is known as curvilinear. Okay, this is an example of rectilinear movement like that, and this is an example of curvilinear. So pergerakan tadi ialah pergerakan curvilinear. Okay, example lain macam ni. Kita bawa motor kan. So we go, and then we have lap, then we go straight, we have another lap, we go straight, we have another lap, and then straight left. So the straight part, this is rectilinear. The curved part, this is curvilinear. So straight part, rectilinear. Curved part, curvilinear. Straight part, rectilinear. Curved part, curvilinear. Another straight part, rectilinear, and the last curved part is curvilinear. This is curvilinear and rectilinear. As a whole, it's still a linear motion because it starts from here and it displays, it changes place in one straight line. Linear motion. Okay. So in this human motion, the whole motion seen as linear. However, to create the motion from bend to straight, you need to have joint action ataupun joint movement. And this joint movement always occur at an axis. Contoh joint knee. So this is the axis of rotation for the knee. Joint dekat bahagian femur. So this is the axis for the thigh. Joint dekat bahagian ankle. So this is the joint for ankle movement. When we have movement at the joint, the movement is going to be some sort of rotational movement. Okay, rotational. So this rotation, and when you have an axis of rotation, this movement is known as angular movement. And combining both linear and angular, so the kicking itself, combining both linear movement and angular at the joint, is known as general movement. Okay, itu 3 jenis pergerakan. Number 4 is oscillatory movement or pendulum movement. Okay, pendulum movement ni dia ada satu konsep you kena faham. Konsep of potential energy. Or we can name it as PE equals to height time weight. Okay, so pendulum movement or oscillatory movement is a movement which start and ends at the same height. Contoh macam batu ladung kan. Okay, we have batu ladung, and the batu ladung will go this way before it return back to the original state. Okay, if we neglect friction, this batu ladung won't stop moving. It will keep on moving until somebody stop that, simply because of potential energy. So if we determine, if we imagine the maximum potential energy to be 1, okay, to be 1. So at the starting point, the potential energy will be 1. At the ending point, the potential energy will also be 1. Why? Because we have the same weight of the batu ladung, and at those given point, the height is similar. Jadi, bila dia pergi ke sana, the amount of energy being restored. So, it has ample amount of energy to move back towards a certain height where the amount of energy will be restored, and it will continue move back and forth back and forth, which will require energy and recharge energy, require energy and recharge energy, require energy and recharge energy, and this process continue. This is what we call a pendulum ataupun oscillatory movement, a movement where the potential energy will be restored at every point of the apex of motion. Kata apex lalu atas sekali kan, at the topmost point of the action itself. This is oscillatory movement. And final movement is wave form, which we can divide into two: mechanical wave dengan electromagnetic. This one visible to our naked eyes. This one is not visible. Okay. Visible dengan tak visible. Mechanical kita boleh nampak. Ombak, spring, all those is mechanical. Electromagnetic, sound wave, apa ni? Sun ray, telephone line, all those things, X-ray, all those things is electromagnetic. It has something in terms of waveform like this, but we cannot see. Itu maksud dia electromagnetic wave. It is not visible. Okay, and when we talk about waveform, there are two different component which is important. The first one is the length of the form. The second one is the compression of the wave. Okay, so to do so, we need to see several things. Okay, the first one is the shape or the longitudinal. Okay, the wavelength being measured from base to base. This is wavelength. So there are wave which is something like this. There are wave like that. So this is a short wavelength. This is a long wavelength. Okay. So why wavelength is important is because longer wavelength can travel further compared to shorter. Okay, longer wavelength can travel further compared to shorter. Example, kita ambil radio. Okay, we take radio. Pencawang radio mungkin ada dekat Tangkak, mungkin ada dekat KL. But if you move from Tangkak to KL, radio transmission will always be there, since the wavelength being used is long wave. Okay, very, very long wave compared to handphone. Sometimes at the same route, you lost signal. Why? Because dia punya repeaters unable to reach you. The wavelength cannot reach you. The wavelength is shorter. So longer wavelength can travel further. Shorter wavelength can travel near. Tapi dia ada drawback dia. Okay, dia ada drawback dia. Okay, first is wavelength. Nak tahu drawback, kita kena tengok yang kedua. Okay, this is length, and the second properties is compression. Okay, if we take a portion of it and we view the wavelength from transverse plane, you are going to see something like this. Okay, this is what we call a compressed wave, and this part is known as an expand wave. Expand wave, compressed wave. Okay, ni saya tunjuk dua bentuk dalam satu spring lah. Sebenarnya dia ada dalam satu wave. The wave, there are wave which is compressed all the way. There are wave which is expand all the way. So if you try to reach very, very far, the wavelength need to be long and expand, and then it can reach further compared to where we have a shorter waveform and compress. Cuma long wave, expand wave can reach further. Saya tulis ni. Long wave plus expand with travel far, but cannot, bukan cannot. Okay, travel far, but penetration power is low. That is the reason why if you are located inside a very thick building, most of the time you can't have radio, you can't have handphone signal because those signal cannot penetrate the wall. Jadi macam mana kita nak ada signal dekat dalam bangunan, we need to have a repeater or a bouncer from outside of the building to go in. So we are going to channel the wave towards the inner part of the building. Itu long wave. Vice versa, short wave and compress equals to travel shorter but able to penetrate. Okay, contoh Wi-Fi dongle dalam rumah. Dia tak pergi jauh, mungkin rumah sebelah pun tak dapat, but satu rumah boleh dapat benda yang sama because it use quite short wave and compressed wave. Ataupun kita tengok ni, kita tengok X-ray. It can go out of the room, it can go there, but it can penetrate your body. That is electromagnetic wave. Cahaya matahari, long wave, very far from the sun. If you go to a very windowless building, there won't be any cahaya dekat dalam. There won't be any sun ray dekat dalam because sun ray is a long wave, expanded. It can travel far away, but it cannot penetrate. So tempat dalam gelap. Tu beberapa jenis pergerakan. Okay, beberapa jenis pergerakan. We have linear, we have angular, we have this one could be linear angular motion, we have general oscillatory wave. Okay, mechanical wave dengan electromagnetic. Ni mechanical wave lah. So two type of properties. First is the length, second is the expansion. Okay, so we have compression dengan expansion, and this is some of the example. So here we have radio wave. Tengok dia punya size panjang. Okay, bila size dia panjang, dia punya energy rendah, so it cannot penetrate. But we go here, it is short, the energy is higher, so it can penetrate a lot. Jadi benda-benda yang ada photon energy yang tinggi means it can go for penetration. In other words, this one is much compressed wave form. This is much expand wave. This is longer wave. This is shorter wave. Ni beza dia electromagnetic wave. Okay, fluid motion tak ada. Alright. Kita masuk kepada yang terakhir ni. I'm just going to discuss a bit about impulse momentum theorem. Ni benda yang kita dah bincang tadi. So the last part is about impulse and momentum. The relationship between I and M. Okay, so I'm going to use one example. Let's take an example of a golfer. Okay, kita ambil golfer. Okay. When we talk about impulse and momentum, impulse always start with force. And this one is internal. Pertama, okay, force dekat bahagian bicep tricep. Force dekat bahagian forearm in order to execute the rotational action. Okay. And this force will be transferred multiple times. First one, from hand to club. There will be impulse. And then from club to ball, there will be impulse. And then from ball to land, it will be impulse. So impulse work this way. Impulse work this way. Okay. What happen is when external force, when internal force being present, it will cause an impulse to be transferred from hand to club. Means here you are going to have movement of the club. You are going to have movement of the hand. Club bergerak, it has movement, it has momentum, and when contact, it has, this ball is going to have momentum, and then momentum of the ball will be transferred to the land. You are going to see some displacement when the ball hit the land. Maksudnya dia pun akan ada pergerakan. And all of this pergerakan is caused by impulse. So when the hand swing, the club has momentum. When the club hit the ball, it will transfer the impulse from the club to the ball, cause momentum. Okay, this one will cause impulse. This one will cause impulse. Jadi pergerakan dia macam tu. Impulse have momentum. Item that has momentum have impulse, transfer to the new one, new momentum. New object has momentum, it will have its own impulse and it will be transferred. Macam tu. Along the way, all the section will have a similar amount of impulse and momentum. So let's take this an example. Okay, kita ambil dia ni. Kita ambil dia ini. Okay, let's say this club, ambil tangan dia. Tangan kita boleh lipat 3. Mana boleh? We can lipat our tangan only 2. Club golf. Baik. Badan. Kaki. Kepala. Hayun. Okay. When you see a hayunan, we have velocity. Okay. So now, the golf club have mass. Berapa berat golf club selalu? Siapa main golf kat sini? Who play golf? Can somebody predict the weight of this golf club? 500 gram sampai 600 gram. Hello, ada orang tak? Are you in here? Ada. Agak-agak berapa berat golf club? Hi, hello. Assalamualaikum. Ada orang tak?
Tak tahulah saya berapa.
Aduh, agak je lah. 0.5 kg. 0.5 kg. Okay. Now, let's try to determine the amount of movement we have at this golf club. Momentum dia. Kita namakan dia momentum golf. Equals to mv equals to 0.5. V ni rotation. Kita assume lah 40. Weh, laju now 40 meter sangat. 20 lah. We get at 20 meter per second. Time with 20. So, kita dapat berapa ni? 10 meter per second. 10 meter per second. 10 Newton per second. This is the velocity or the momentum of the golf club. And when the golf club collide with the ball, it will transfer an amount of impulse. And this amount of impulse, let's say the contact between the club and the golf ball occurs at 0.5 second. Sekejap je dia contact sebelum bola tu pergi. So, there will be an amount of impulse being transferred. This amount of impulse can be measured by This one, M. Jadi impulse dia Ft equals to M. Okay, since M kita dah tahu 10 sama dengan F T dia 0.5. So F equals to 10 bahagi 0.5. Berapa ni? Newton. So this is the amount of force we have in the ball. This ball is going to travel. Okay, this ball is going to travel. If this ball, the weight of the ball is 100 gram. So now let's find out how fast this ball travel. Dia akan patah balik semula. So kita akan dapat impulse equals to mv. So impulse is 20. Impulse dia berapa? Force is mass velocity. How much is the impulse? Berapa impulse contact ini? How much is this impulse? Jawapan ada kat atas. Berapakah impulse bola golf ini semasa contact? The answer is up there. It's not 20. 20 is the amount of force. Okay, this is F. So how much is the impulse? The impulse is 10. Sama impulse dia, okay? The impulse is 10, but now the ball is 0.1 kg V. Jadi V baru berapa? 10 bahagi 0.1. Equals to 100 meter per second. This is how we transfer from momentum of golf swing. So this golf swing, okay, which move at 20 meter per second, resulting the ball to travel 100 meter per second. Ini cara untuk kita guna. Okay, so by having this 100 meter per second, how much force we have in the ball now. Sekarang kita dah ada bola yang travel pada kelajuan 100 meter per saat. How much force this ball presents if the ball land and the contact between the ball and surface takes 0.8 second. Dia land 0.8 second sebelum dia bounce. So kita nak tahu at instant of the land how much force being transfer. Berapa force dia yang kena transfer. So kita akan gunakan balik momentum equals to F T. We have the T, we try to find out the F. Momentum dia berapa? Berapa kelajuan, berapa momentum bola tu sekarang? So you just use the new equation. 0.1 times 100 equals to F 0.8. So F sahaja is berapa? So 0.1 kali 100 sama dengan 10. Jadi F sama dengan 10 bahagi 0.8. So the ball contact resulting 12.5 Newton of force being transferred during the collision. Apa tak? 1 M resulting contact, 1 I. When you have I, you have M. And when this ball land, you have another I. This is how we use concept of impulse momentum theorem. Meaning that for every collision, you are going to transfer impulse. And when an object have an impulse, it will have an amount of momentum. When an object have an amount of momentum, it will have impulse to be transferred to the new one. So impulse is transferable. Okay, it is transferable between object, and it causes the object to have momentum. So how we transfer impulse? By having collision. Inilah konsep impulse momentum theorem. Okay, nanti kamu bacalah nota yang ada dekat sini. Mana nota ni? Ni nota ni. So please have a look. Okay, you may try the equation dekat belakang ni. Contoh macam ni kan. Okay, contoh macam ni. So we have impulse being transferred. Impulse ni datang daripada mana? Movement of karate chop. Okay, and this movement cause impulse to transfer, cause force. Okay, and this force cause motion. And this motion inflict another force to the batu. Okay, contoh macam ni. Bola bergerak, it has impulse. It has momentum. And when contact, orang ni akan rasa sakit, bola akan travel ke arah yang lain. Why? Because this person also inflicting impulse to this object, but in different direction. Okay. Right. So last concept for today is known as conservation of momentum. Okay, meaning that when we have an object with an amount of momentum, it goes in a direction and met with another object with a momentum. Okay, dia pun mungkin bergerak. Mungkin sikit lah. When we have this situation, meaning we have a situation of collision. Always remember M1, okay, plus M2 will equals to a new set of momentum, ataupun kita namakan dia sebagai M3. Meaning, the momentum is not going to dissipate. Instead, it's going to change. This is the conservation of momentum. So, throughout the system, momentum amount will remain equal. Jadi, kita kena faham. Momentum consists of M and V. How to be equal is either M increases or V decreases, or M decreases, V increases. Along the way, kalau tadi contoh ni 10, ini 10, lepas berlanggar, dia mesti ada 20. It will remain. Dia tak boleh, before collision ni 10, ni 8, lepas berlanggar 28. Mana datang lagi 10? It's not like that. That is the principle of momentum conservation. Okay, so saya bagi contoh. The formula that in interest here is momentum 1 plus momentum 2, which is M1 V1 plus M2 V2 equals to momentum 3 equals to M1 plus M2 V. Ni formula yang kamu kena guna. Example, we have a person move there, another person move there. Let's say this person is 80 kg, this person is 70 kg, this person travel at 10 meter per second, this person travel at, let's say, 16 meter per second. So, we want to know, after they collide, what happened? Ni cerita principle of momentum conservation. Yeah, this is the story of it. So let's calculate this one. So we have 80 times with 10 plus 70. Now is the tricky way. When we have this kind of equation, please take a look at the direction. Always take a look at the direction. Okay, velocity is a vector, means it can go both way. Cuma anything that move to the right is always positive. Anything that move to the left going to be negative, and nobody is going to talk. Nobody is going to remind you about this. Just remember on your own. When we involve calculation of velocity, this symbol play a very important role. Okay, so dia bukan lagi 70 kali 16, it will be 70 kali negatif 16 equals to 80 plus 70 V. The new V we don't know yet. Okay, cuba selesaikan ini dulu. 800 tambah dengan berapa ni? 70 kali 16. 1120. And that is going to be negative. Equals to 150 V. So dekat sini kita dah boleh selesaikan. 1120 tolak 800. It will be negative 320 equals to 150 V. So the V itself is going to be 320 divided by 150. 2.13 negative meter per second. Meaning of this answer is that after the collision, the new complex will actually move to the left hand side at a velocity of 2.13 meter per second. Along the way, the momentum before and momentum after is equal. Meaning the amount of momentum is not dissipate, but it's going to change. Change in terms of what? Tadi dia bergerak laju, now dia bergerak perlahan. But the mass is changing. The shape is changing. This is principle of momentum conservation. Contoh macam kita ada kereta dengan bas. Okay. Berlanggar. Apa jadi lepas berlanggar? For sure lepas berlanggar, dia dah tak ada kereta dengan bas. Dia akan jadi separuh kereta, 3 suku bas. But this new complex will have the same amount of momentum for these two. The only change happen is towards the shape and towards the new velocity. This is principle of momentum conservation. Okay, M1V1 plus M2V2 equals to M1 plus M2V. So try to remember that one. For further clarification and example, you may have it from the notes. Okay, kalau kamu buka notes ni dekat bahagian belakang, dia ada cerita tu. But this is the example of momentum. Okay, and then this is another example of the same momentum. So the question will be what happened after the collision. Ni formula dia. So you may have some of the example here and to before collision, after collision. Okay, before collision is M1V1 lah. Ni dia tertindih ni. Ni after collision dia dekat sini. M1 plus M2V. Dapatlah kamu jawapan ni. Okay. So that will be the end of our topic for today. This one is the example for interaction between impulse and momentum. So I equals to F, T, M equals to MV, the thing that we have discussed. So kamu boleh tengoklah dekat situ. Okay, ni momentum principle of, summation of force tu kita dah bincang sebelum ni. Okay, do you have any question for our topic today? Ada soalan?
No, sir.
Tak ada. Simple je kan? Kita ada 3 benda. Newton first law, second law, third law, which talks about how movement occurs and the interrelation between all those 3 Newton law. And towards the end, we have impulse momentum theorem, where every single collision will cause impulse to be transferred from one another. And when an object have impulse, it will have a momentum. And these 2 properties will be channeled down. Okay, it will be channeled down. It will be transferred from one object to another object by collision.